everyone, hope all of you are doing well. In this video we are going to discuss the textbook questions and numericals related to distance, displacement, speed and velocity from the chapter motion. Today we can start with the first question in your textbook, that is in page number 100. The question is, an object has moved through a distance. Can it have zero displacement? If yes, support your answer with an example. The question is about the magnitude of displacement. That is it possible to have a zero displacement even when the object has moved through a distance? So to answer this question, we have to know what is displacement. We have studied that displacement is the shortest distance measured from initial to final position, right? So to understand the concept, we can consider an example. Suppose a boy is walking to school from home and the school is 1 kilometer away. After reaching there, he is coming back to home also. In this case, what is the initial and final positions? What is the initial position? Initial position is the home and final position, it is also home, right? So what will be the displacement? Displacement is the difference between initial and final positions. So that will be 0, isn't it? Because the initial and final positions coincides in this case. Then what will be the distance in this case? So we have studied that distance is the total path length covered by the object. So in this case, is it possible to have a zero distance? No, because the object has moved 1 kilometer, or the boy has moved 1 kilometer to reach the school and 1 kilometer back to home also. So total 2 kilometers he is traveling. So what will be the distance? So that is 2 kilometers, right? So the distance is not asked in your question. I just told to understand the difference between these two. Okay, now we can answer the question, right? That is, yes, an object can have zero displacement even when it has moved through a distance. This happens when final position of the object coincides with its initial position. For example, one more example is given here. If a person moves around park and stands on place from where he started, then here displacement will be 0. So please understand, the distance will never be 0 and displacement may or may not be 0. Okay, hope it is clear to you. We can move to the second question. This is a numerical problem. The question is, a farmer moves along the boundary of a square field of side 10 meter in 40 seconds. What will be the magnitude of displacement of the farmer at the end of 2 minutes 20 seconds from his initial position? It is given that the farmer moves along the boundary of a square field. That is, the field has a square shape and each side is 10 meter. Also, the time taken is given as 40 seconds. We have to calculate the displacement of the farmer after 2 minutes and 20 seconds. Okay, hope the question is clear to you. Now we can represent it diagrammatically. Suppose the square is ABCD. Okay, the farmer is starting from end A and then goes to B. From B he is going to C, and from C he is going to D, and finally from D he is again going back to end A, so that he completes one square, and the time taken to complete one square is 40 seconds and each side is 10 meter long. Now we can write down the quantities given here. That is, side of the square field is equal to 10 meter. So if you know one side, we can find the perimeter as 10 into 4, that is equal to 40 meters. Okay, then the time is given as 40 seconds. Now we have to calculate the displacement after 2 minutes and 20 seconds. So this 2 minutes and 20 seconds is not in SI system, so that we have to convert it into SI system. Okay, so it will be 2 into 60 seconds, that is 1 minute is 60 seconds plus 20 seconds. So total will be 120 plus 20, that is equal to 140 seconds. And since in 40 seconds the farmer is moving 40 meter, therefore in 1 second distance covered by the farmer will be 40 by 40 is equal to 1 meter. So what about 2 seconds? In 2 seconds it will be 2 meters. Okay, so we can calculate in 140 seconds the distance covered by the farmer will be 140 meter. Okay, now we know that in one rotation he is traveling 40 meters. So how many number of rotations will be there to cover 140 meter? Okay, so to find out that, we can use this total distance divided by perimeter. Okay, so that will be 140 meter divided by 40 meter, that will be 3.5 rounds. Okay, so in to complete one round he is taking 40, so such 3.5 rounds he is traveling to complete 140 meters. Okay, thus after 3.5 rounds the farmer will reach at point C of the field. Now again we can go back to the diagram. Here the farmer starts from end A and again coming back to end A when one round is completed. Okay, like that he completes 3 rounds. After that he starts from end A and reaches till C only, as he is traveling 3.5 rounds. Okay, now the initial position is end A and final position is C. Now we have to find the displacement of the farmer. Okay, so what is the displacement in this case? We know that displacement is the shortest distance between initial and final positions. So that will be AC in this case, straight line distance. Now to calculate AC, we can consider the right angle triangle ABC. And when we apply Pythagoras theorem, we will get AC square is equal to AB square plus BC square. Therefore, AC will be equal to root of AB square plus BC square. Here, each side is 10 meter. Therefore, AC will be equal to root of 10 square plus 10 square. That is 100 plus 100. And that will be equal to root of 200. That is root of 2 into 100. The square root of 100 is 10. Therefore, we can write it as 10 root 2 meters. And the value of root 2 is 1.414. So, we will get the answer as 14.14 meter. Now, we can move to the third question. The question is, which of the following is true for displacement? A, it cannot be 0. B, its magnitude is greater than the distance traveled by the object. We have already discussed that displacement can be 0. Therefore, the first statement is false. Now, what about the second statement? We know that displacement is the shortest distance between the initial and final positions. Right, therefore, the displacement will be less than or equal to the distance. That is, the second statement is also false. Therefore, we can answer the question as none of the statements is true for displacement. First statement is false because displacement can be 0. Second statement is also false because displacement is less than or equal to the distance traveled by the object. Now we can discuss the questions given in your textbook, the page number 102. Okay, the first question is, distinguish between speed and velocity. We know that speed is the distance traveled by an object in a given interval of time. And what about velocity? Velocity is the displacement of an object in a given interval of time. Okay, and the equation for speed is distance by time, and the equation for finding velocity is equal to displacement by time. And we can write down one more difference, that is speed is a scalar quantity. What is a scalar quantity? A quantity having only magnitude. Okay, so that speed is a scalar quantity because distance is scalar. And what about velocity? Velocity is a vector quantity. What is a vector quantity? It has both magnitude as well as direction, because displacement has both magnitude and direction. Therefore, it is a vector quantity. So, velocity is also a vector quantity. Okay, so we can differentiate between this speed and velocity. Now I am going to conclude this video. The rest of the questions will be discussed in the second part.